And welcome to the Ammonia Bunkering and Port Operations Digging into Detail webinar. It's great to be running another one of these. This is number 7, I believe, of the Maritime Insights webinars from the Ammonia Energy Association. And today we are going to have, we hope, an extraordinary hour with Maja Bendtsen, the CBO Bulk at Rønne in Bornholm, Jan Gramkov, the Process Safety Manager, Risk and Safety Department at Ramboll, and Nicklas Koch, the Project Manager in Maritime and Energy at DBI, the Danish Institute of Fire and Safety Technology. So as we're starting off here, just to let you know, this is being recorded, and there is a notice to this effect in the chat as well. So, as we normally do, a quick introduction to who are the AEA, the Ammonia Energy Association, is a global non-profit industry association that promotes the responsible use of ammonia in a sustainable energy economy. The AEA's mission encompasses both the decarbonization of ammonia for existing applications, as well as the adoption of low-carbon ammonia in new applications, including direct use as a fuel for electric power generation or maritime transport, and then direct use as a hydrogen carrier and carbon-free energy commodity. With initial foundation rooted back in 2004, the AEA membership now includes something around 176 corporations around the world. We are the Maritime Directorship of the AEA and are working to bring the maritime industry into the low-carbon ammonia fuel opportunity, while also helping to empower the ammonia industry with an offering towards the maritime fuel sector. So what are these webinars about? So we are handpicking, with the cooperation of participants, select initiatives from around the world which illustrate how solutions are being found and progress made towards the implementation of maritime ammonia fuel. So we're trying to raise levels of understanding and to connect stakeholders. So on the Ammonia Energy Association website, you'll find summaries of these, most of them, and recordings of the webinars. So don't worry, you can always catch up if you've missed some, and we'll keep putting them up there. It takes a little while after the webinar, but we do get them all up there. Next webinar will probably be in November. It's not finalized yet. Maybe in the second half of the month, probably after the annual Ammonia Energy Association conference, which is taking place 14th to 17th of November in Phoenix, Arizona this year. The conference will have a strong maritime content as well, and there's still time to register. Nod, nod, wink, wink. About today. So this is a very special project which is going on in at the island of Bornholm, as we mentioned. And to those who don't know, Bornholm is a relatively small island belonging to Denmark, located in the Baltic Sea to the east of Denmark. Not far from where I'm sitting in southern Sweden, actually. And I've heard the phrase green gas station of the Baltic. So what is going on out there? This sounds really interesting. Let's just move on quickly to Maja, who knows all about it. So we'd really like to hear from you, Maja.
Thanks, Conor. And I don't know if you can see my slides yet. They are on their way. So if you just jump directly to slide number 2. Yeah, so first of all, I'm Maja. I'm working for Port of Rønne, and Port of Rønne is that small yellow dot on the squared island right there in the middle. So you have Sweden to the north, Poland to the south, Germany southeast, and southwest, and mainland Denmark to the west of us. And yes, we were the ones who had recently had a gas leak from the Nord Stream pipelines very close to us. What I want to show with this map is the massive expansion of offshore wind that will be built around us in the Baltic Sea. So far, the Baltic Sea haven't really been used that much for offshore wind, only just above 2 GW installed. but by 2030 we will have almost 20 gigawatt installed, and the potential for the Baltic Sea is 93 gigawatt in total. Bornholm itself will have, first of all, we'll be one of the 2 Danish energy islands, so we'll have 3.8 gigawatt offshore wind installed just south of Bornholm. And then there is also a private developer who's looking into developing 2 times 1.5 gigawatt east of Bornholm. And all this offshore wind, of course, gives the potential of producing ammonia using the Power-to-X technology, and that is part of the investigations that we're doing in the Bornholm Bunker Hub project. So if we jump to the next slide. So here you see a bit further out the map of the Baltic Sea with Bornholm right there in the middle. We have plus 60,000 vessels passing by every year. It's expected to increase to 80. The Baltic Sea is in general one of the most busy sea areas in the world. We are having 15% of all shipping is going through the Baltic Sea. So really a lot of traffic. And what we want to do is we will investigate the possibility if we could be a future bunker hub or the green gas station of the Baltic Sea for some of all those vessels passing by. Then we also have a community-based ferry service that are looking into multiple options for a greener future. And in that, there is also potential for using green fuels, which could, for example, be ammonia. And our ambition is that we will be ready already by 2025. Some have asked me, can you actually be ready for that? And I say, I don't know, I hope. That's part of all the investigations and the work that we are doing. And that's also the reason why, as you see here, we have huge industry partners as part of the project, because we do not want to develop this alone as a port, because we don't have the competences to know everything, and therefore we need partners from the entire value chain to be part of the discussion and investigations. And next slide, please. So as I said, we are also looking into the possibility of doing Power-to-X production on Bornholm, and we have decided in the Bornholm Bunker Hub project that investigating potential Power-to-X production is such a a specialized topic that we needed actually to do our own project just based on that. You see the partners out here to the left, where we both have industry partners and university. Local authorities is also involved, and this is based on the establishment of the future Danish energy island with 3.8 gigawatt capacity, of which 800 megawatt is what is called overplanting, and therefore could likely be used for Power-to-X production. So what we are looking into in establishing the business case is what are the availabilities of green power? Do we need more than offshore wind, for example? There are some considerations about size and configurations that can take many forms. I mean, there are many different technologies for producing ammonia, and which will be the likely product. And also many different sizes that you can build such a plant in. Then we are looking at the market, how this can be integrated with the local energy system, and then of course also where can we actually locate this? Where could we locate a plant? Where could we locate storage? Also, because Bornholm at the moment do not have industrial complexes of this size. You could say in general in Denmark, we are not used to having chemical industry, and the Power-to-X plant is, in my view, chemical industry, and that is quite different from what we have today, and therefore also something that we need to look into. Where could we locate this? Where could we locate storage? How do we deal with this in a safe manner and get local residents to accept that we also do this? And then besides the business case and outcome of the project is actually also some simulation tools that future developers can use to do techno-economic analysis on, for example, size and configuration. basically being able to fast simulate different scenarios for Power to X. So yeah, that was some of the work that we're doing here in Bornholm.
Thank you, Maja. That's a lot to take in, honestly.
Yeah, and I was quite fast, I think.
Yeah, but yeah, we will come back around to you with some questions. So if we can park that overview for a moment and move on to Jan. Jan, with Ramboll, you have been doing some really detailed investigations into the safety side of this. So we'd be really interested to hear what you can tell us about that experience.
Yes. Well, firstly, my name is Jan Gramkov. I'm process safety manager. I've been so for 15 years, and I'll be talking about risk assessment, consequence assessment, and risk mitigations as it applies to ammonia, storage ammonia bunkering, basically. And this is what we've been helping the bunker hub with this past year and a half. If you can go to slide 3, basically. Risk assessment in its basic form is likelihood and consequence, a combination of this. And what you do is you identify risk, or at the right side of the slide, you assess the risk by a combination of likelihood and consequence, verify whether risk is acceptable. If it's not acceptable, you have mitigation, you apply mitigation and reassess. And if it's acceptable, you go on to further design iterations. And if this creates new risk, you go back and identify again. That's a basic way of doing risk assessment. When doing risk assessment, risk acceptance criteria is important. Risk acceptance criteria come from national regulations, comes from standards, sometimes for current accident levels, if you don't have anything else to go by. And standards are what we base a lot on, and standards are based on industrial standards, how things are performed in the industry, best available technology, mitigations learned from past accidents, but always remember to verify that the standards you use are applicable. And you also need to reassess the risk. Is this sufficient? Next slide, please. One part of the risk assessment is the consequence. And when we're talking about ammonia, the properties of ammonia is important, especially when we're talking about loss of containment, which means that ammonia slips out of the containment. If you have refrigerated ammonia, this is cooled down to boiling temperature or below. If you have a release of this, you have a pool of ammonia, which evaporates with heat inputs, creates a cold, heavy vapor. This is then dispersed, and at some point it's heated up enough so it has liftoff and dispersed in the atmosphere. So the consequence of refrigerated ammonia is ground-wise to a certain degree, to a certain distance. Whereas if you have semi-refrigerated ammonia or pressurized ammonia, you have flashing, because when you have a release, it boils when it is released, and this gives off an amount of gas which is far greater than the evaporation itself. So when you have semi-refrigerated or pressurized ammonia, the amount of gas released in the accident is larger. You still have a pool, you still have a heavy gas spread, but this cloud of gas is larger. It moves further before it's heated up to ambient temperature and has liftoff. And the real issue here is the higher the temperature or pressure, the more flashing, the more dispersion, the later the liftoff. So choice of storage method is very important for the risk profile and what happens if you have loss of containment, which is one of the things that people are afraid of. Next slide, please. When we have storage of ammonia, the storage tank is one of the things we're looking into. We can have different types of storage tanks. We can have single containment tanks, which is a tank in a basin. So if you have a loss of containment, the basin catch the ammonia liquid, but you still have evaporation, you still have spread. This is the same for both pressurized and non-pressurized ammonia, but of course the amount of vapor is still larger. That's one option for safeguards against accidents. You can have double containment atmospheric tanks. There you have a gas overflow, and because of the area of evaporation, the cloud is less, so you have less consequence. If you have double containment, either pressurized tanks, which are very expensive and more difficult to maintain, or double containment on atmospheric tanks, refrigerated ammonia, you have overpressure risk, and in case of overpressure, you still have dispersion of cold gases. So there's a lot of considerations around the choice of tanks, which also has a price tag. So it's very important to settle in early which risks can we afford in acceptance and in the area where we situate the storage. Next slide, please. So storage mitigation, it's choice of tanks. We have a standard for that, which is basically built for oil products and gas products, but ammonia is mentioned and it's a guide, but it's centered around liquid containment, and it states that gas releases are acceptable. This is why I say you need to look into standards. Is gas release an acceptable risk in your case? So there's a lot of issues around that that need to be clarified early on. There's also the point about storage near risk-sensitive areas. Do we need gas containment for risk mitigations or not? Some of these gas containments can be achieved through terrain, through how you make your layout around the storage area. You can divert the gases as long as they're heavy, and once they're lighter than air, they disperse into the air, so it's easier to handle. And the bonds themselves can be designed to retain the gas. Tank inspections on atmospheric tanks are not mandatory everywhere, but I've seen national regulations that require this anyway. So that's another risk mitigation that you need to consider, the possibility to have tank inspections on atmospheric tanks. Next slide, please. The loading and unloading area contains the least ammonia, but it has actually the highest initial likelihood of loss of containment. It's also the area which is hardest to achieve containment and retention, because it's an open area. You have the ship, you are bunkering the ship. You can have structures that divert the ammonia into the water, for instance, to ensure that the water absorbs all the ammonia before it's dispersed as gas. So there's options, but it's harder. So mitigations on the loading, unloading is more on limiting the amount of release. So it's ESD, which is mandatory everywhere. You can have dry breakaway couplings to ensure that you contain the ammonia, have less output, you can access flow out. So there's a lot of options there, but these are later additions. It's the structures, layout options that are most important. And that's it for my slides.
Thank you, Jan. I have a load of questions. Just to the audience, you have a Q&A option there. You can write questions in there, and now's your time. This is a great moment to write your questions in. If things are not clear to you, we will try and cover as many as we can. Meanwhile, shall we move on to Nicklas? We're doing good on our schedule so far. This is great. Nicklas, take us away.
Thank you very much. So let's get the slides up. So at DBI, throughout the past couple of years, we have worked a lot with human factors and public perception and perception of safety. And I'm going to take you through some of the things that we have looked into. And if you can switch to the next slide, Julian. I am going to give you 3 examples here that are slightly different from ammonia, but carries a lot of similarities, especially when it comes to safety perception and what people they think of it. So you have safety perception on the road, for example, but most people they drive. Many people they sit in their car every day. They go to work. They go shopping, and for most people, they consider this activity to be safe, especially because they are the ones sitting in the vehicle. They are the ones that have control over the vehicle. This also means that if you have complete control over what you're doing, then surely this is safe unless I make a mistake myself. We also have safety perception at sea. We have thousands of years of history sailing, and many people would consider a boat ride to be completely safe. Many of us also book cruise vacations and sail on them just for the sake of fun. And the same goes for flying. Now, what these things they have in common is that both flying, sailing, and driving is essential to operate in the modern world. And I think we're moving into an area where power to X will also become an important part of our lives and the way that we live. So when you then look at the safety and then try to combine some of it, and how should I say, you look at the safety of an electric vehicle, for example, you can see that if it's parked in your garage, because of what you get from the media, people they will likely think it's perfectly safe to park a car in your garage. And if you then get into a situation where there is a fire, then you would still consider it to be okay, whether it's one type of vehicle or another. But in the case of an electric vehicle, because of some of the media hype that has been around them, some people may consider it safer to have a more conventional vehicle in there because of things such as difficulties with extinguishing electric car fires. If you then put that on a ship, and then try to put that in the context of safety there, then you could have electric car fires on a car deck, and because of the safety perception that you have there, you can get into a situation where you have trained staff dealing with electric fires that knows what's going to happen, and then you can have a hotel staff that has another idea of what's happening. And the point that I'm trying to make here is that safety is perceived differently depending on who you are. If you are hotel staff, you could have read the media. You could have seen it as it being particularly dangerous to have an electric car fire at sea because of it could be hydrogen fluoride emissions or others, while sailors would handle it differently. They would approach it as any car fire, meaning that this different perceived level of safety has a huge impact on the actual safety level, because it may be more dangerous for the sailors to go in and extinguish the car fire. It may also be less dangerous with an electric vehicle. And these are all things that needs to be taken into consideration when talking about perception of safety. Can you go to the next slide, Julian? So when talking about perception of safety and public perception in relation to power to X facilities, it is very important to communicate directly with the public when establishing Power-to-X facilities around. It's important to generate public awareness so that the information that they will get does not come from, how do you say, sources that have not properly documented the actual safety risks, because the perceived level of safety can have an impact on whether you can actually construct this Power-to-X facility, and maybe also on the actual Power-to-X facility safety itself. So the earlier that you can generate public awareness of the technologies that you're trying to implement, the better, or the more time you have to share the knowledge that you have about a specific technology and make people aware of the risks associated with them, so that you don't get into a situation where speculations take over instead of the real risks. So public involvement is key. When establishing a Power-to-X facility, monitoring the public perception as you go is a key aspect of establishing any facility, whether that be Power-to-X or introducing other technologies. And what a Power-to-X facility project owner would like is likely to get public acceptance. The only way that you can gain public perception, as we see it, is through being straightforward in your communication, being honest about safety levels, and informing the public, both yourself and through third parties, to make sure that the risk level is documented fairly, and the risk level is how do you say, is realistic. Can you go to the next slide? So the key takeaway messages when establishing Power-to-X facilities is to listen to local communities, listen to what their concerns are, try to address these concerns, and always communicate, always be straightforward. And the earlier you can involve people in this process, the better. Thank you.
Thank you, Nicklas. That's really interesting, and I think that I'd like to start exploring a couple of questions that came to my mind as you were speaking there. Are you saying that the perception of a level of risk, you said safety, but the perception of the level of risk can actually influence, first of all, how did I write it here? Operationally, how you mitigate risk. So you gave the example of a car fire on a ferry.
Yeah. And
depending on the appreciation of what that risk presented, it was going to influence whether or not they even fought the fire. Some of them may say, no, that's an electric car on fire. I'm not fighting that fire. That's far too dangerous.
Certainly.
Because their perception is that's a more dangerous fire to fight than a fire on a traditional car.
Yes. So
it may not be the case at all.
So depending on how safety is perceived in that particular scenario, you can end up in a situation where people, they will not fight the fire, or people, they will attempt to fight the fire. Whether an electric vehicle fire is more or less dangerous than a conventional car fire, I think that's something that still needs to be investigated. But there is definitely an indication from the studies that we have done in relation to safety and the perception of safety, that depending on who you are, where you get your information from, you may treat certain scenarios differently. And the car fire is just one of multiple scenarios. that we have investigated, where we can see that people, they react very differently depending on what source of information that you have available at the time, especially when it comes to the introduction of new technologies where you don't actually know what it is that you're dealing with. Well, I'm saying that you don't know what you're dealing with. In that case, I'm talking about the people that have not yet been informed of the risk. Which is why communication early on is so important, to not have a misunderstanding of the actual risk level.
Yeah, it's absolutely fair to people should make the best assessment they can with the information they have at hand. I mean, that's human nature. But actually, also, Jan, just sticking with this kind of the car, actually, the safety side. I don't think everyone necessarily understands this very fundamental thing of risk is a combination of the likelihood and the consequence. So, and sticking with the car, for instance, with a say a seatbelt. So why do we wear seatbelts in cars? So the way I see this is, if you looked at how often you actually have a car crash and you're at risk from injuring yourself against the steering wheel or whatever, you may think that wearing seatbelt is not that critical, because some people go through their entire lives and they are never involved in a car crash. However, the consequence, if you do have a car crash, is extremely high. So overall, the risk level is high enough that it merits installing seatbelts in cars and wearing them. Is that a good analogy to what you're saying about the basic appreciation of how risk is evaluated?
Well, seatbelts are a mitigation, which means that past experience has shown us that cars crash once in a while, and when cars crash, people get hurt. If they're not wearing seatbelt, they get more hurt. So they've introduced seatbelts. They found out that that was not always sufficient, so they introduced airbags. They introduced that the steering wheel was pushed away during accidents, and a lot of other things. We've also instituted traffic rules, regulations, to ensure that people abide by the same rules. So we have a lot of mitigations enforced into driving in the traffic.
Yeah. And I think that if there was no such thing as private people driving cars, and you said, let's just make big roads and they can all drive down the road at over 100 kilometers an hour, people would be saying, absolutely no way, that's ridiculous. But when you put all the mitigations in place, what was an unacceptable risk becomes an acceptable risk. Does that make?
Yes, that's because at the moment, the likelihood of you being killed in a car crash is less, because we've reduced the likelihood of that consequence.
Yeah.
The risk that you have an accident has not changed that much. Of course, there are some of the new technologies in cars today that brake automatically, but putting that aside, the likelihood of a car crash is the same, but the consequence is lower.
Yeah.
So that has become an acceptance, because then it's only material damage and no life.
Yeah.
So
we have some very well built and tried and tested systemic ways of managing risk in the world. We are certainly, my generation is certainly so used to this being all around us, we take it for granted, but actually there's a huge amount of effort goes into this. While I'm talking to you, Jan, I was looking at your tanks and your double-walled and buns and everything, and I can see there's various options, and you can have pressurized ammonia and cold ammonia. And I think also that maybe some of the audience the subtleties here involved, I think, in what this is. So I'm also going to try and simplify this and take it out of context. Outside in the barbecue we have here, there's a cylinder of LPG, and that is not that dissimilar in terms of physical properties to ammonia, I think, right? It's
both pressurized gas.
Yeah. So we have that for our barbecue, and what you're saying is that's contained at ambient temperature. So it's 10 degrees outside here today. That's contained at ambient temperature. And if I open the valve, I want some to escape because otherwise my barbecue won't light. If it was cooled, so you're talking about a cooled ammonia here. If that was cooled right down, very little gas will actually escape, right? Because it's cold. It's not producing gas. It's just a liquid.
Well, if you cool a gas down, LPG or ammonia to its boiling point, then the pressure inside the vessel will be atmospheric pressure.
Mm-hmm.
So in case of an accident, there'll be a puncture of the tank. The amount that comes out will be less. There's less force, there's less pressure.
Mm-hmm.
And when it comes out, it's already at boiling point. So it will just evaporate like your kettle on your stove. If you took the same kettle and used a pressure cooker and opened that mid-boiling, you have a huge amount of vapors escaping instantly. Flash boiling. Exactly the same when you have your ammonia at a temperature higher than boiling point. It would be the same as storing water at 110 degrees. And the liquid will try to relieve itself down to boiling point and below, which will result in this extra gas release. The energy needs to be released somehow. That's by boiling. And that generates the additional risk when having not cooled ammonia. Okay.
So ideally, it's kind of better to keep it cold. So if you're keeping it cold, and I know there are systems for keeping it cold, and you can insulate the tanks, which is a better, if you like, a safer way to contain it. I was just wondering, is it possible if it starts to warm up and your tank can't contain that pressure, and then you have to release some of the pressure? Is it possible to flare ammonia?
Yes, it would be possible under the right conditions, but these need to be developed. I don't think there are any developed yet, but you should be able to flare ammonia, or you can use a scrubber. Ammonia is very soluble in water.
Oh, yeah.
So you can dilute up to 25% of ammonia in water. So you can actually run the flaring, you would call it, through a water basin and absorb the ammonia instead, and thus avoiding release of toxic ammonia.
Oh, that's a much better option. Yeah. Yeah. Okay. Switching now a bit more to the business side of things, Maja, when you're looking at this project in Bornholm, there are plenty, and maybe some of the audience here will relate to this. There are plenty of not the same, but similar projects going on around the world. Do you have much contact with them? Is there much collaboration? I mean, particularly for safety, for instance.
Yeah, we try to have as much collaboration as possible. And actually, I didn't mention this project here, but we are also part of a project called the European Green Corridor Network, led by the Maersk Mc-Kinney Zero Carbon Shipping Center in Copenhagen, and cooperation with the ports in Rotterdam, Hamburg, Gdynia and Tallinn. And I'm very happy to be in that project, because we, as a small port, do not have the same capabilities as those larger ports have, for example, with regards to safety. That's also the reason why I lean towards Jan and Nicklas to understand what it is that we need to do. But seen from a commercial point of view, for me, it is very important that we try to have as much standards as possible. Now, we've spoken a bit about electric vehicles. I was a part of an electric vehicle project starting in autumn 2008. And at that point, there was a lot of talk, at least in the project, about smart charging of electric vehicles, so being able to time the starting point and how to integrate with the energy system. And this was really very hype at that moment, at least in the energy industry. And then we ran into problems in the project because the standards wasn't there. So we had 4 or 5 different plugs for charging of vehicles. We had different protocols for controlling the charging, proprietary protocols, and things like that. And my, you could say, fear for this introduction of new fuels, and this goes both for methanol, even though that is more developed than ammonia, and especially ammonia, is that we will have, say, different standards, different ways of doing it. And I could be afraid that if we have that, then the implementation will take longer than necessary. And here, I'm, of course, specifically thinking about how do you bunker a vessel. Jan also already mentioned the need for different safety measures, that we have the same safety measures across the industry, so that we don't end up, having every port have their own system, because that will only prolong the introduction and implementation of these new fuels, and I don't think that's a good idea.
Yeah. In your investigations, Jan, have you found, maybe it's not completely in your area, but I guess you've been looking into ports and what regulations may apply here when it comes to bunkering ammonia. Have you any thoughts on that?
Well, we have looked a lot at the oil industry, because they've have years and years of experience with bunkering stuff like LPG and LNG, and some of the same properties apply. So of course, we look to the standards that's been developed over the years from the accidents that has happened, and we pull in knowledge from the fertilizer industry, from the cooling industry, and so on. So we basically gather up all the information we can from different sources and combine it in a way so that it can apply to bunkering of ammonia. That's basically what we do. This is combining of things we already know, and ensuring that we don't miss something along the way.
So the cooling industry you mentioned there, as you went through that list, that was, can you tell us about ammonia in refrigeration? Well,
ammonia in refrigeration is often pressurized. You are at other temperature setups, especially if we are using these as heat pumps, where we go way up in pressure. And the cooling industry have developed a lot of standards on how to maintain a good environment for containing ammonia. So we have a lot of information there. They also sometimes work in vacuum below boiling point, so we have information there. So it is basically combining existing knowledge, and the standards that we need to develop are the interface standards. How do we ensure that things are compatible? The ship is compatible to port and so on. Both during the bunkering, but also loading, unloading, when receiving new ammonia, if that's the case, and so on. So question of standardization of all these interfaces, so things work together. You have the same agreements. You have a lot of procedures in the IMO regarding how you do bunkering and so on, that we can steal, basically.
So we're going to get people to collaborate, bring in all the information that exists, including from the using ammonia as a refrigerant in the cooling industry, which I don't think a lot of people are aware of, and then try and look for, okay, so we take ammonia, we're not bunkering heavy oil, we're not bunkering LNG, we're bunkering this new thing. What learnings do we have from different industries? What can we share and standardize? And then bringing in the human element. Nicklas, I guess, you know, you guys must be interested in the operational side of this. You can set up the design, you can set up the procedures, you can do everything. You can set it up as well as you can, but at the end of the day, people have to operate this. In a port setting, is there any? Have you had any thoughts about, you know, what's different about in a port setting on a ship, with the interface between a ship and a terminal with an unusual fuel? Talking about risk perception and management from the human factors point of view.
I mean, humans, when dealing with any kind of operation, there's always when you involve a human, there's always an introduction of new risks, but it's important to remember that the human itself is not the source of all risks. The human can also sometimes be a mitigation. And that's something that we have looked into to quite a bit. So it's always important to consider the human's role in a risk assessment when it comes to how bunkering operations are being done, and to some degree the human can be considered a safety mechanism, and to some degree a human can also be considered a risk in itself. So that's how we're looking at it.
So training is very important.
Training is very important. The better trained the people are, the higher the security level is going to be, and the better informed the people are about why they're trained the way that they are, is the higher the security level is going to be.
Why they're trained the way they are. Yeah.
That's another factor that often plays a big role. That is that you tell people what to do, but you don't always tell people why they have to do what they've got to do. So helping the people that are working with it to understand why they're doing the things that they're doing is also a key aspect, which is something that people are very, very good at within the engineering industry, both onshore, offshore, and energy, whether that would be power to X or wind or whatever that may be.
So I guess this goes back a bit to people's how they perceive risk. So when they see themselves as an essential mitigating factor for that risk, they're going to act differently. They understand their role is part of the mitigation. And to that point, with the emergence of ammonia, and what we're talking about ammonia here, Maja, we're looking at having all this in place, and I think you mentioned perhaps 2025.
Yeah.
Perhaps 2025. Do you think that's an ambition?
And it's an ambitious ambition, I know.
Yeah.
Because there are so many tasks that we still have to solve if we want to be ready. Fortunately, regulation is on its way, but it is not there yet. And one thing is having the regulation. The next thing is then actually implementing, and also as Nicklas mentioned, having people accepting the regulation, the safety, that the regulation is risk mitigating enough. There are so many different factors that has to play together, and then we also have to remember that this takes time. There was a question I saw in the chat about how much time is used for approval. Well, I know that just for tank storage, at least in Denmark, the approval process is 1.5 years just to be approved according to the CBO directive. And then we still have the building permits and the environmental permits and all the other things that we need to have. So this is, and I think that is also important for us to acknowledge as an industry that if we want this to happen, there are so many things that has to happen at the same time if we want to lay this puzzle. And we have to remember that there is some lead time, and that is also the reason why we go out as port and raise our hand and do a lot of investigations already now, because we know there is a lot of lead time before we are ready. But on the other hand, I think it would be terrible if we end up in a situation where, for example, the ship owners come and say, hey, we want to use this fuel or that fuel, and then we as ports and the entire value chain is not really ready to serve that. So we need to, we talked also before about collaboration. Now we have a collaboration with the ports, but we also have the collaboration across the value chain and dialogue with different shipping lines, bunker providers, storage providers, because we need to work together to solve this, because it is such a puzzle to be ready in time. And if we do everything in a waterfall model, it will take 2 years before we are ready. I think we need to work together and do things simultaneously, because there are so many tracks and open questions that we need to work on at the same time.
So collaboration is key. And do you also have ambitions to export ammonia or other parts of fuels to the UK?
Yeah, that's a possibility, right? So right now we're doing this Power-to-X feasibility study, looking at the possibilities of producing Power-to-X on Bornholm based on the 800 megawatt oil planting from the future energy island, the wind parks there. And we are looking into what will we be able to produce. But to be honest, I think, and I can be jumping to conclusions here, but I think that ammonia will be a likely candidate. And that is because, well, first of all, we are an island, so we have a limited potential supply of CO2 unless we do direct air capture, where the technology is not really there yet. So we cannot really do any of the carbon-based fuels. And I must admit that for hydrogen, I see a huge challenge in export. If we are all other types of export of hydrogen than pipeline, I see a huge challenge because of the very low volumetric energy density. So that's the reason why I see ammonia as the most probable candidate to produce at a Power-to-X plant. And as we probably wouldn't be able to utilize everything, then yes, then we are looking into potential of export. It's important for me to stress here that we as port authority, I mean, I represent the port authority. We are 32 people in total. Half of us is working in the office. The other half is working out there as linesmen and blacksmith and whatever we need to operate the port. So we are not looking into doing future, we do not imagine that we will be operators of either Power-to-X plants or tank storage or anything like that. But we see our role right now as a facilitator to ensure that this development actually can happen by bringing the right people together, and then also reducing risk. So by doing some of these initial investigations, trying to find out how much, for example, by discussions with Jan, how much can we store, where can we store, how should we store, and all these, then we have reduced some of the risks that later investors will have. So we thereby increase the likelihood of this actually being realized, and especially being realized in time, because that's really a challenge I see. That's the lead time of development, which is very long.
Yeah, it's often, you know, repeatedly we hear ammonia is among the front runners for future maritime fuels and as a hydrogen carrier. And then there's always this, if the safety concerns can be ironed out. And
there was actually a question about this on the chat, asking about the price. And now I cannot remember the exact numbers. Definitely ammonia will be a more expensive fuel to use than traditional fossil fuels. No doubt about that. And then comes the question, how expensive or how cheap can you produce ammonia? So what is the additional cost? And again, the energy density, lower energy density of ammonia compared to fossil fuels will also help increase the price. But when we look at, or through our cooperation with the Maersk Mc-Kinney Zero Carbon Shipping Center, they have done some investigations looking at what will be the price per energy, not per ton, not per cubic meter, but the price per energy. When we are looking at the future fuels, what will be the cost of CO2 reduction per ton for the future fuels? And there, ammonia is a very high on the agenda, because it will be one of the lowest cost of reducing CO2. It will be lower than, for example, e-methanol.
Yeah, and
but as you said, the challenge is the lack of regulation, and can we do this safe and all that. And I cross my fingers that we can, because I think that we as an industry and as a society need that we can actually use ammonia for fuel.
And I would just say that question was answered by someone else in the chat, by Ralph Matlak, and while I think that's very good analysis, as soon as you drop a carbon price into this discussion, the whole thing changes and it becomes more like what carbon price would be required. So we mustn't lose sight of the fact here that we are trying to decarbonize the world, and there will be market-based measures coming out of the EU and the IMO almost certainly in the future. So we need to, the complexity is a little broader than, you know, equivalent price, etc. And when we look to the future, the reason why there's so much interest in ammonia for many applications as a fuel is because of the expectation that there will be a market-based measures to change, dramatically change the business case for ammonia, among other things. But as I say, having a discussion like this around safety, has been flagged constantly about if we can sort out the safety, then ammonia has a very strong future. This is an ammonia group webinar, so I'm bound to say that, but it's actually true. It's been borne out by many other people who could be seen and completely independently. And there's a question here from Alex Farquhar, someone known to us. Question for Jan: what about the personnel in proximity to a loss of containment? And that's quite a broad question, and we have no time left for it. But if you could give us a one-liner response to that.
Well, ammonia is toxic, and accidents will probably happen. So it's a question of lowering the likelihood of that happening to a level where we can live with it. Like car crashes, we live with it, even though it's there.
Okay. For all the other unanswered questions, both from registrants and in the Q&A here, we try to keep these things within time. We all have to go back to other things. Please don't hesitate to reach out to us at the AEA. There are addresses there. You can get in contact with us. We'd love to have these conversations so the discussion doesn't have to end here. And we apologize profusely for not having enough time to cover all your questions. I'd like to round up. We have 3 minutes left. I'd like to round up and do the last question to the panel. It's 2030 and we have a business as usual ammonia bunker fuel operation at Rønne port. Ships are coming in, they're bunkering ammonia, and it's systemic, it's understood. What 3 main challenges have we overcome to get there? Nicklas, start with you.
I think that you have managed to communicate the safety level in such a way that it is being perceived and seen as being acceptable, because it's from my point of view working towards public acceptance and working towards handling the public, as some people have done in other industries. That's a mistake to do. That's wrong. So what you have done is you have managed to communicate safety levels properly, and the community has understood the safety levels and have accepted the safety levels. So that's what you have done.
Thank you. Jan?
Well, you manage the interface between the ship and shore. So you established a common interface between these two. So you can bunker everywhere, anywhere, with any port, any ship. So it is possible to have it broadened out, basically.
So that interface comes straight to mind there. Yeah. And Maja, you have covered a lot of this question already. But if you had to
I would say we have managed to put all the right stakeholders together.
Yeah.
That is really, in my view, that is really the biggest challenge we have right now, because this is so complex and it takes a lot of time. What is it? We have spent 100 years or 70 years on having liquid fossil fuels spread all over the world and build the infrastructure to do that. And now we want in 8 years' time to do the same for ammonia and methanol. that's ambitious.
The greatest challenge ever, perhaps. Yeah. Okay. I'm seeing 1 minute before the hour here, and we could be here for another 2 hours, I'm sure. I see loads of interesting questions in the Q&A. I'm really sorry we can't get to them all. They're all valid. The information is all there. The AEA, we are working on bringing out a lot of information to the public, answering many of the questions that come in these webinars. Thank you very much to Maja, Jan, and Nicklas. Thank you so much. It's been really great to dig into this. We don't normally get in this deep, and I really hope that everyone watching has enjoyed and got as much out of it as I have. We'll see you again soon. I don't want to take up any more of everyone's time. Thank you very much.